given a conductor with free charge carriers inside, to drive the current through it, we need to apply potential difference between its terminals. When the potential difference is applied between the terminals of any conductor, shown like this. Now, let us say this is positive and this is negative. And I'll say normally a DC source like this of V volts. This DC source of V volts, when I just say in network analysis, it says the potential difference between the ends of this device is V volts. Check it. It is capable of creating the potential difference between the terminals because somehow it basically has two conductors in which there is positive charge on one conductor and negative charge on the other. If it is left alone, the charge on the conductors remains fixed. And the potential difference between the terminals is the value of minus integral E bar dot dl bar in the region between the conductors of this EMF. I will just appreciate it as a capacitor. When I talk about the potential difference, there are two conductors for sure, kept at different, it's actually no cell. There is an electrolyte, there is one conductor, another conductor, one is positive, another is negative with respect to that, because of which there is a potential difference, you know. That is a part of chemistry for us. Now, listen carefully. When we connect a conductor between the terminals of this voltage source with plus and minus, whatever happens in capacitor also will happen here. The electrons which are more on the negatively charged conductor will now, positive charge will not flow. Positive charge will not flow. Only electrons will flow everywhere. Even in semiconductors, we say holes are there which is positively charged. No, the hole is basically nothing. Hole moves to the right if electron moves to the left in the valence shell. Okay, that discussion is different. But wherever there is current, in the conductors or semiconductor, it is essentially electrons that constitute current. Positive charge won't move. Positive charge resides in the nucleus. And in an electrolyte, positive charge can move because there are ions, positive and negative ions in a liquid. But here, these electrons automatically will go through the path provided by the conductor and reach the positive plate. Any source of EMF, the voltage source we call it, requires energy continuously to supply the current. For what energy is required? To maintain that potential difference to be at V volts, the source either uses chemical energy or mechanical energy or solar energy, whatever it is, to do what actually? To maintain the potential difference between the terminals to be equal to V volts. Whichever the electron that reaches the positive conductor should be immediately pushed onto the negative plate. I know that this requires energy. Through the circuit, through the resistance, electrons will reach the positive terminal, try to reduce the voltage between the conductors. To maintain the voltage at that point, whichever the electron comes and reaches this should be pushed onto the other conductor, so that the voltage is remaining constant. It's something like this. Here we should know, given fixed number of electrons in the system, pakka, electron cannot come from space into the circuit. There are electrons inside the conductor. There are electrons on the conductors of the source, because of which there are fixed number of electrons. And whenever this electron comes and enters this, whatever the electron which is there at this end goes out, keeping the number of electrons inside the conductor fixed. It has to continuously circulate electrons to constitute the current in the circuit. For that, we need to pump somehow energy inside the source to transfer the electrons from the positively charged conductor to negatively charged conductor. It is something like this for us. You have fixed amount of water in a tank. In a fountain or whatever. I want to continuously circulate water through a pipe. Let us say this is the pipe. To continuously circulate water to the pipe, through this pipe, I will use a motor. We will give the electrical supply to the motor. From the lower tank, water is sent into the upper level tank. Once the water reaches upper level tank, it will come down automatically through this conductor at the rate determined by the radius of the pipe and the ability of the pipe to allow the water to pass through it. It will automatically come down like current going through the resistor. To continuously circulate water, we have to keep the levels of the level of water in both the tanks fixed. Means at whichever the rate, this is what is important. At whichever the rate water comes down through this pipe, you have to bring the water up using this motor. This is what voltage source does actually for us. For electron, higher potential is negative potential. Correct? Lower potential is positive potential. It automatically goes from negatively charged conductor to the positively charged conductor. If it were to be a capacitor, what will happen? If I connect a conductor to a capacitor like this, electrons will flow and come to the positively charged plate. And in transients, we will see that after some time, current through this resistance becomes equal to 0. And it exponentially decreases at the rate given by the time constant, RC. Because there is only passive resistance connected between. There is no energy supplied to the capacitor here. So energy is stored in it. I will connect the resistor. Electrons now go back to the positively charged plate to reduce the negative charge on one plate and positive charge on the other. After some time, there will be no potential difference between the terminals of the capacitor, because of which there will be no current through the resistance. If you want to continuously circulate current through it, we need to have a source. Check it. At some point of time, we should have discussed this, because we should go to network analysis, taking the concepts in electromagnetics. Now check it. Whenever we want to drive a current of 5 amperes through a resistor, through a conductor, we need to apply potential difference. We cannot straight away create electric field intensity. We need to apply potential difference or create potential difference between the ends of that conductor. When the potential difference is created, between the ends of the conductor, electric field intensity is created inside the conductor. Please check. Electric field, correct only, no? Consider a uniform conductor of uniform cross section. If I create a potential difference of V volts with this polarity between the ends of this conductor using a voltage source, if the length of the conductor is L, there is electric field intensity to the right everywhere. And the strength of electric field intensity E is equal to what? V by L. If by chance, there is a case actually for us. The conductor is of non-uniform cross section. Continuously varying cross section. A practical case for us. Apply a potential difference V volts. if you create a potential difference of V volts between the ends of this conductor, there is fixed amount of positive charge on one end and same amount of negative charge on the other end. Definitely yes. When there are two conductors in a system, because electron cannot be brought from outside. If one end is there with plus Q, another end will be there at minus Q. That these are the charges corresponding to the terminals of the voltage source. Now, the electric field lines, they go like this. Very important case for us actually. Check it once. Means the electric field intensity at any point on the cross section nearer to the left end is maximum. As we move to the right, I think you are able to understand, right? The electric field intensity will decrease in its value because the number of flux lines is fixed. As they diverge, we know that density of flux lines straight away represent the strength of electric field intensity in any medium. As I go to this point, it is still lesser, and at the other end, it is minimum. Definitely, there is a voltage V between the ends of this conductor. That V is no doubt integral E bar dot dl bar from one end to the other end, again is the field. Minus E bar dot dl bar. In the first case, because it consists of a set of parallel lines, electric field intensity is same everywhere and it is directly axial. But in the other case, electric field intensity is not purely axial. The lines are inclined. Electric field intensity is inclined. Any doubt here? Please check.